Hello guys, I'm back. My name is Jeferson Costa. I'm a chemical process engineer with expertise in plant design, and today I will share with you a little bit about vessel separators and how we use the aspen hysys and some kind of drawings, engineering drawings, P&IDs, and etc. in order that you get more familiar with what chemical process engineers must know to work with plant design. So sorry, I am a little bit late. Usually I start at 9 a.m. here in Brazil. Now it's 9:20. But if you are seeing the recording, it's not an issue. And I have some notifications. The first one is that every day or almost every day I'm doing live sessions in my Instagram. And during the Brazil morning, before I start my working day, I do a live session talking about what I did in the previous day in order that you have a chemical process engineer diary. So if you want to participate, if you want to do live questions during this live session that I do every day, feel free to do that and connect with me in Instagram and you will be notified. When I have persons that wants to connect with me during the live sessions to do questions, I connect them and it is not an issue for me. And it is very nice because here in YouTube I am not able to do that, but in Instagram I can connect with people in real time and receive the questions. Another thing is that if you already know my YouTube, if you already know my content, please, not please, but if you getting good advices and if you are learning something here, click in the like button because I have a goal for this channel, and my goal to my YouTube channel in 2021 is to reach 100,000 subscribers. Will you help me to get this amount of subscribers? If you like the content, you should help me, because this way I will be more motivated. I will push myself more to share much more content related to chemical process engineering and plant design. And finally, to start this presentation, let me talk to you. If you didn't do yet my free training about chemical process engineering plant design, it is still time. It is more than 7 hours of free training to learn more about P&IDs, process simulation, field activities, and etc. in order that you get familiar and more skilled in chemical process engineering and plant design. To subscribe to my free training, you can find the link in the description of this video or go to my website, jeffersoncosta.com. So enough talking, let's discuss about the subjects of today. So it was not easy to find subjects for today because I was not too much motivated to do a live session today, but as my commitment, I am here. And this weekend I will record some classes to my in-process booster training program related to separator vessels, how to do the separator vessels, process data sheets, P&IDs, and etc. So I'm getting this opportunity to share with you a little bit about this subject in order that you get more familiar about that. And the truth is, if you use the aspen hysys, the standard vessel separator in aspen hysys to try to design a vessel separator, that is not the correct way. That is not the way that you will see in the field. So because of that, I will bring to you some references for fundamentals calculations. As you know, here in my YouTube channel, I don't teach you how to do the calculations because it is something that you are supposed to learn in your college or in your university. But now I'm trying to bring some references in order that if you didn't learn that yet, you can get deeper in this subject. And I forgot to say that, but it's always very nice to know where are you from, and I have seen Sandino. Long time I don't see you, Sandino. Thanks for being here with me. And talking about the references, the first references that I recommend you to get familiar with is the GPSA Electronic Engineering Handbook. So let me be a little bit smaller right now. Just a moment. So this is my first reference to you. If you wish to work with chemical process engineering, plant design, and especially if we talk about the gas processing, the engineering data book, GPSA engineering data book is a very, very good source of information, and I always take a look on that to prepare my classes and also to solve problems in my work, because it has not only the fundamentals, the calculations, the principles, but it has a lot of examples, and you are able to evaluate your learning and doing hand calculations. And what is interesting is that you can get those examples and transport that to Aspen hysys in order that you can evaluate one result from another, and with that consolidate or improve your skills in process simulation. So my first tip here when we talk about vessel separators is that you take a look in the GPSA engineering data book. And just to give you a little bit of a taste of what you will find there, I have here my electronic copy. So the section 7, separators and filters, there is all the fundamentals about these subjects. So it talks about filters, scrubbers, knockout vessels, and etc. So you should know, based on the university learnings, that the vessel separator, the main design of the vessel separator depends on the velocity of the fluid in the vessel. Talking about separation from gas to liquid, what will define the diameter of your vessel is the fluid flow through your equipment. So here is the theory behind it. And what is very, very nice in the GPSA is that it talks not about the principles to do the calculation, but also how you consider the vessel drawing, because the vessel separator is not only the strafe distance to separate the liquid from the gas, and I focus on in the liquid and gas separation, but you can extend this information for three-phase separators and etc., and it is everything here. Okay, so what I want to let to you, when we use the Aspen hysys SPI standard, only getting the vessel separated object and adding to your process simulation, what the Aspen hysys will give you most often is the diameter and the strength length of the equipment. But we need to consider more than that. We need to consider space to have the liquid content. We need to consider a space for alarm level, and we need to consider a space for high alarm and shutdown levels. And the amount of space or the amount of volume that we will consider will depend on the standards that you are following, and it comes from there is some run of thumbs and numbers, but most often when you are in a design company, the design department already have the guidelines to you choose how much hold up you need to consider for oil and gas, how much you need to consider to three-phase separators, and etc. So I will not get in details about that. What is important to me is that, and I will show you it in the aspen hysys, is that the vessel separator in the aspen hysys, the main purpose is to show you the heat material balance for two-phase flow and what goes out from liquid and what goes out from vapor. And when we do chemical process engineering plant design, when we talk about vessel separators, we must consider more than that in order to be able to specify equipment and install that in the field. So the GPSA is a great source of information for that. So I strongly recommend you to take a look and be more familiar about it. So let's go to the aspen hysys, and here I have a feed with real informations. So the composition that I have in this feed is based on a real case, and as you know, I am a chemical process engineer that works with plant design, so I work as a chemical process engineer, and every time in my free time I dedicate part of my free time to share my experience. And although I have some mentoring programs, I have a training program to help people how to use the aspen hysys applied to plant design, I don't live off selling courses. So that's why I have some real information to share with my students. And this particular stream I will share with the members of my in-process Telegram channel. So if you are if you are a member of my in-process Telegram channel, you can use this stream to start your own process simulation in aspen hysys. And so here we have a real composition from a project that I have, and the main view of the project is that I have a depressurization system, and I have a mixture of gases that has light gases and not so light gases, but they are always all of them are in gas phase. But as I do a depressurization, the temperature reduces, and depending on the level of the pressurization, part of these gases may condensate. And because of that, I have a heat exchanger, and it is a shell and tube heat exchanger with the shell using hot water to do the heating of this gas in order that I can vaporize the condensates that was formed during the operations. If the heat exchanger is working well, there is any problem, I will always be delivering gas to the customer. But if I have some kind of fail in my heat exchanging system, I can have a temperature drop in this condensate or in this stream, and because of that I can form, or I can have condensation forming in the line. So to prevent the condensate to reach my customer, I need to have some kind of device to collect this condensate. So what I will show here to you is some of the considerations that we did when we were doing our plant design. So just to remember you, it is based on a real case. And let me just fix a parameter here. So here I have the conditions of operation. So if everything is okay with the operations, I will have this kind of condition in my system. And if I do a double click in the stream, you can see that my vapor phase is 1. So I have 100% of my feed gas as my feed stream as gas. So let's add a vessel separator to evaluate how much liquid can be formed and how we handle this kind of information in plane design. So if I go to model palettes, if I go to separator, I have the object separator added to my process simulation. Doing a double click on that, I can add the inlet stream and I can add the outlet stream. And remember that at the top of the equipment you will always have the connection for vapor phase, and at the bottom of the object I will always have the liquid or condensate phase. And you can see that in terms of heating material balance, the aspen hysys are already converted, and as is expected, I have 100% gas phase. I should have, or I must have, 100% of the gas going to the VAP stream. So if we go to the worksheet, we can confirm that. So liquid stream 0 and vapor stream the same as the inlet. But it is not what I want to show you. What I want to show you is how to do a preliminary sizing of the vessel. So to do a preliminary size of the vessel, eventually you can go to the rating and choose the type of equipment that you want to. And in this case, I want a vertical separator because I have more gas than liquid, and it's just a matter to form the droplets of the condensates to settling down. And you will observe, as we don't have any liquid going out from the heating material balance, usually the usually the aspen hysys will be able to do a quick sizing. And you will have this kind of message to you because you want to do a sizing of a vessel separator that is not separating anything. So based on only in the operation conditions, would not make sense to do a vessel separator in reality because we don't have anything to separate. But I must consider, and it is some of the activities that we do in plane design, I need to consider the safety conditions of the system. So I have a heating system, but this heating system can fail. If this heating system fails, what will happen to my gas? And according to the inputs information that I have, the temperature of the temperature of the stream, instead of being 50 Celsius degree, it will be 20 Celsius degree. That is the inlet conditions to my heat exchanger. So for now, let's use the 20 Celsius degree and see what happens. When I consider that my inlet stream is at 20 Celsius degree, the vapor phase decreases from 100% for 9500%. So 95%. So it means that 5% of the stream was turned to condensate. And another question that we can answer to using aspen hysys is, eventually you will talk to me, Jefferson, if I want to have gas, what is the minimum condition that I should consider to have my stream at 100% gas? You can answer these questions in many ways. One of the way is if I delete the temperature and if I consider that my stream is 100% vapor. In this case, it is a saturated condition. Any drop in the temperature will lead to condensation of the, or partially condensation of the stream. So the minimum conditions for not having condensate in my stream is 38.6 Celsius degree. And we are talking about engineering. We need to have safety margin. We need to consider that our process is not at fixed state conditions. There are variations. I can have variations because the weather, and because of that, what we decided is to, instead of using 40 Celsius or 38 Celsius degree at the gas temperature, we used the 50 Celsius degree. Another way to evaluate this is using the case analysis. So if I go to case analysis, and I already have this one, let me delete this one. So if I click on add, and I want to evaluate which are the behavior of the stream based on the inlet based on the temperature conditions, and it is one of the tasks that you can find in the Aspen hysys expert user certification. So take a look on that. So I have the independent variables, and in this case my independent variables is the temperature. I want to evaluate a range of temperature, what will happen with my gas stream. So I will click on find variables, and I want to evaluate my feed stream. So I click on feed, and I will look for temperature. So it means that I want to do a variation in temperature and see and verify one result. So the dependent variable is what I'm looking for right now. So I want to verify the condensate formation. So let's click on find, and now I am also evaluating the feed stream, but you can do a variation in a stream and verify the results in other stream, depending on the process and depending on the objective that you have with your process simulation. And in this case, I want to evaluate the vapor fraction because I want to know what is the behavior of the gas based on the temperature. So I phase fraction, I click in the arrow and done. So I have my independent variable, I have my dependent variable, and now I go to the case study and I can set the range of analysis. So I will start from, I know that the minimum temperature is 20, but I will start with 10 Celsius degree, and I will finish with 60 Celsius degree. When I do this, I need to define the step size. So I want to evaluate for each Celsius degree, or I want to evaluate at each 5 Celsius degree, or about a group of 10 Celsius degree. So to let it shorter, I will let as the step of 5. So the Aspen hysys automatically calculates 11 steps. Once I did that, I will click on run, and you can see that the evaluation was already performed by Aspen hysys. And now there are two ways to evaluate the results. There are the table where you can see for each temperature what is the vapor fraction. So here, based on the step size that I informed to Aspen hysys, my minimum pressure, operating pressure, should be 40 Celsius degree. And the other thing that's most very, very helpful is to use the plot. So based on the plot, I can see the behavior of the gas once I'm increasing the temperature. So once I increase the temperature, I increase the vapor fraction until I reach 40 Celsius degree, and it would be my minimum my minimum operating temperature. But as safety margin, we choose 10 Celsius degree, and thinking about control of the system, what we can do is my my operating pressure, my operating temperature at the discharge of the heat exchanger will be 50 Celsius degree. But if for any reason my temperature transmitter identifies that we reached 40 Celsius degree, we will have an alarm to alert the operator that something is not good, or that something is wrong. So, or we can define it that instead of the alarm being 40 Celsius degree, it can be 45 Celsius degree, and so between the 45 and 40, the operator has a time to do some kind of verification or some kind of actions to avoid the formation of condensate. And if the formation of condensate is too critical to your process, we can set that at 40 Celsius degree, the station should be shut down, because if I form liquid for any reason, I have a big, I will need to pay thousands of dollars because I didn't comply with the requirements, or because, for instance, if I'm talking about rotating a compressor and I sending gas to the compressor, I cannot have liquid, and if I have liquid, I can break equipment that costs $2,000 million. So this is the way that we do plan design in real life. Okay, so and now that we have a feed stream, we have a gas stream with composition and flow, and we have a liquid stream with composition and flow, it is possible to aspen hysys to do quick sizing of the vessel separator. So I will keep with the vertical size, and I will click on quick size. Sorry, I find the minimum temperature, but I didn't add to the feed stream. So sorry for that. Let's consider the 20 as the minimum, and now it should be okay. So when I do that, the aspen hysys do the calculation of the diameter and of the H of the vessel separator. So this is the simplest way to do sizing of a vessel separator in aspen hysys. But as I told you, it is not so simple to get those information and tell to the supplier that, oh, I need a vessel with this diameter and this weight. Now let's add that to the field. It's not the way that it happens. A way to get values more accurate related to the diameter and weight, and you can use the GPSA calculations to verify if this calculation is okay or not. What I just remind you is that the diameter is a function of the fluid flow or the gas flow that you are entering your equipment, and based on that there are a series of calculations that must be performed. Okay, but to get more close to real equipment, what you can do is, instead of using the quick size, you can go to equipment sizing tab and click on vessel sizing. This way you will find another menu that address to the design of a vessel separator, and here you will have a more detailed information. So I need to choose the separator that I have in my process simulation. If I click here, select separator, in this case I have only one, but if you have multiple vessel separator in your process simulation, you will select what you want to, and I click on OK. And based on the information that is already available in the heating material balance, the aspen hysys did a quick calculation. So let's verify some tabs here. If we go to sizing, we can add some kind of specifications in order that the aspen hysys will consider that to do the preliminary sizing of your vessel. And remember that it is a preliminary sizing. And we can choose here we have three specifications activated. We have the length per diameter ratio, we have the liquid residence time, and it was assumed by the aspen hysys, and we have the demister to top, so the distance between the demister and the top of the vessel. And if we go to construction, there are some information related to materials and cost. If you have a cost estimative, or if you have cost references, you can upload this information here, and it is possible to use the aspen hysys to find the best economical between the diameter and height, but we will not use we will not talk about that right now, okay? But it's possible to do that. What I want to show you is the performance. In the performance, you will find the diameter of the vessel, and the diameter is the same that was calculated or not. Let's verify with the process simulation. So here, the diameter, you can see that it is the same. And the total length is 2.5 meters. Let's verify with so the H is the same. But we have some considerations here. We have LL shutdown, and we have the residence time, and we have the vapor space diameter. So we have a series of other information that is not clear when we are using the quick calculation. But this by itself is not enough to buy a vessel. And I will tell you now why it's not, why just it is not enough, because we need to consider the instrumentation, we need to consider a series of design parts in the equipment that are not clarified in the aspen hysys. What I'm talking about that? Let me show you, returning here. Here is the P&ID. I will talk about that in the end. So here is a template for a process data sheet for a vessel separator. So what we must consider when we are doing a specification or a plan design that includes a vessel separator in our design. We need to consider these main fields here. So we have the L that represents the seam to seam part of your vessel separator. You need, and it is what the aspen hysys is considering in its calculation, is the seam to seam size, because you can see that the geometry of the equipment is flat cylinder. So I have a flat interface at the top, a flat interface at the bottom. So it doesn't consider in Portuguese we say calota, or in English is the spherical part is not considered in the aspen hysys. So we must consider that in terms of layout conditions or layout plot plan analysis, okay? Because if you have, it is important to maintenance, it is important to the pipe engineer when he or she is doing the isometrics, everything must match. So it's very important. Here you can see that the nozzle, it is at the side of the equipment, but it could be at the top of the equipment. So all of this is very, very important and must be informed in a process data sheet or specification data sheet in order that the supplier, the manufacturer, are able to manufacture equipment that fits to our needs. And we have some others consideration here, so let me a little bit higher. So we, in general, what we have as per calculation is that the distance between above the nozzle and below the nozzle is 2 times the vessel diameter. So it is what you will see in the GPSA calculation. However, we must consider a space for liquid hold up, and here I taking into consideration a company's procedure. So it says that this minimal volume to liquid hold up should be 2 minutes. So we must consider 2 minutes, and you have seen in the aspen hysys that for this specific case, let's see here. Just a moment. Yeah, we can see here at the performance that the liquid residence time is not 2 minutes, and 2 minutes is the minimum, but as I considering that it is a gas that is not supposed to have condensate, I don't want 10 minutes of hold up because it will increase my vessel age, and if I increase my vessel age, I have more metal used to construct or to manufacture the equipment, and it will be more expensive if I consider to having 2 minutes residence time. So you can see that we have here 10 minutes, and it could be 5 times lower. And with that, what will happen is that the age of my equipment will be smaller. And I have considerations about the above conditions for the nozzle, and when we do equipment, a vessel separator, a vertical separator specification, we must identify where is the orientation of the nozzles, because when we go to the pipe instrumentation diagram, it seems that everything is at the same side. So the vessel separator that I was talking to you in real life is this one. So you can see that at the first sight, since that the taps for the level gauge is at the same side as the level switch for shutdown. So it is not necessarily right. What will define that is not the pipe instrumentation diagram. What will define that is the data sheet or the specification data sheet of the equipment. In this case, this equipment, there is, and it is the template, okay? Based on the template, we will build the specific conditions for our project. So if I have a nozzle here, I must identify the other nozzle here. So if we are talking about the taps for the level gauge, most often we'll let the both nozzles at the same side. So we'll add a nozzle here and identify nozzle A, nozzle B, for instance, and etc. So what I want to show you here is that from the process simulation and the equipment at the field ready for operations, there are a series of documentation that the chemical process engineers must develop. And one of them is the process and specification data sheet for equipment. And I have another example here, and it is for the horizontal separator. So you can see that there are some requirements also, and it is not only get the process data, add to the aspen hysys, and okay, everything's great, now I can print my process simulation and send it to quotation. It's not the way that happens in real life. And now I will show you what the up to this point I was showing you the process specification datasheet. It is what the engineering department do during the plan design. But once it is finished, we send that for quotation, and we receive quotations for multiple suppliers, or if your company has a shop, pipe shop, or its own fabric to build the equipment, they will build the vessel or the equipment for you, but in the end we need to receive the real construction, or the final drawing, the certified drawing for the equipment. And this equipment is the real representation of this one here. So what you can see here in the piping and instrumentation diagram is this one. And it's just coincidence, but the level tabs for the level gauge is at the same side of the level switch. And you can see here, as I told you, we must inform the orientations of the nozzles. So I have the inlet nozzle here, I have the tab nozzles for level indication and for switch here, N3, N6, and we have a table of correspondences, and we have more two nozzles here. So if you go to the drawing, we can identify here each nozzle, its size, and also the description. So I have N1 as gas liquid inlet, N2 is transmitter level for the low tap. I have also the N5 is the high tap. I have the drain, so N6 is the drain. And if you go here, N6 is the drain. Oh, sorry. And it is at this side. And the N2, N5, let's see what it is. N2, N5 is the taps for level transmitter. So before the manufacturer is authorized to build this vessel, this drawing returns to the engineering team in order to evaluate if everything is correct. It's according to the process datasheet or specification datasheet that we did. So in the end, we will receive a certified documentation confirm that it was the design considered to build the equipment. But before building the equipment, there is a time I work in some project that we have, for instance, 10 days to do the comments in the manufacturer drawings to confirm that the nozzle is in the correct size, and if the direction of the nozzles is in the correct size. I need to evaluate if the nozzle's pressure rating is correct or not, because believe me, sometimes it doesn't come correctly. It gets for some mistakes, it gets different than it was supposed to, it was considered in the process data sheet. And it is an example of that, because you can see that there are a triangle here with one, and it means that it was a modification. Sometimes the modification is because of the manufacturer, sometimes the modification is because of the customer, but modifications happens, and we need to certify and we need to approve the documentation before the equipment is constructed or manufactured. And here we have another set of information that I will get in more details with the members of my training program. So guys, in terms of overview of equipment, this is it, what I would like to share with you. Thanks a lot for being with me up to this point. I surpassed the pass at the time. I believed that it would be very fast, but took more time than I wished to. I have a meeting with one of the members of my training program. But if you have any questions, please let me know, because I'll do my best to answer you. So this is it. Oof. If you don't have any questions, it was very nice to be here with you. Follow my Instagram, because I'm doing every day, I'm doing live sessions there to talk about my routine as a chemical process engineer working with plant design. Today I will do a live session. Let's only confirm if my student is ready for the mentoring. Okay, he must be waiting for me. So as we don't have any question, it was very nice to be with you, and we meet. I meet you soon in another video. Bye bye. Hi, process chemical. I have two trainings. One is available in my platform. If you go to jeffersoncosta.com, you will find the aspen in-process booster, aspen hysys. It is a training dedicated to teach people about how to use aspen hysys, how to use the aspen hysys. The main objective of this training is to let the members know how to use the aspen hysys. But I have also a mentoring program, and the mentoring program, it's not open all the time. I open in specific dates. Currently, it's not open. And to know how to join it, or when I will open more seats, you must be following my content in the internet, or if you join the in-process Telegram, I always notify the members for the next batch. Okay, so this is the way that you can join my trainings. And the in-process mentoring is different from the in-process booster hysys, because it is a mentoring program. You will find not only how to use the aspen hysys, but also how to read and develop pipe instrumentation diagram, and you'll find also how to develop this kind of process data sheet, specification data sheet that the chemical process engineers must know to work with plant design. So this is it. I must go, guys, and I'll see you soon in the next live session. Bye bye.